Hello guys, welcome to another video here. We are going to be reviewing a little bit and then we're gonna talk about area, okay, and then finding some and doing some interesting problems related to area. Okay, so let's go ahead and get started, guys. First of all, again, we are using that formula sheet that it's available for you. So that formula sheet is what you're gonna be using in here. So number one, we're going to be using the formula for 2 secants. So if you look at your formula sheet, the formula for that should be b plus a plus b is equal to d and c plus d, where, okay, this right here is a, this right here is b, this right here is my c, and this right here is my d. Okay, actually, yeah. Okay, the b in this case is 5, the a is x, the b again is 5, the d is 4, the c is 6, and the d is 4. Okay, so we got 5x plus 25 is equal to 6 plus 4 is 10, times 4 is 40. You know, subtract 25 on both sides, you get 15. That means that x is equal to 3. Okay, and that is your answer for number 1. All right, let's keep going, guys. We have this right here. Let's take a look again to our formula sheet. I'm going to use the same formula I used for this one right here. It's the same thing. So on this one right here, our formula once again is b, and then a plus b is equal to d plus c plus d, where this is my a, this is my b, this is my c, and this right here should be my d. Okay, so the b in this case, the b is x minus 7, and I do like to put it in parentheses there. The a, we're going to substitute that with x minus 5 plus the b, which is x minus 7. Okay, the d in this case is 4, the c is 2 plus the d again, which is also 4 again. We're going to add x plus x there. We're going to get 2x minus 12 is equal to 2 plus 4 is 6. 6 times 4 is 24. Okay, we're going to distribute that. Now we have x times 2x is 2x squared. X times negative 12 is negative 12x. Negative 7 times 2x is negative 14x. And then negative 7 times 12 should be let me verify that. Should be 84. And it should be positive 84 is equal to 24. Okay, so we're going to add this one plus this one together. And that should give us 26x. Subtract 24 on both sides, you should get 60 right there. Since those are all even numbers, as you can see in there, what we can do is divide all those by 2. Okay, so divide by 2 and you should get x squared. You should get x squared minus 13x plus 30 is equal to 0. When I factor this guy, I should get x minus 3 and x minus 10, which means that x is equal to 3, or x is equal to 10. So in this problem, we actually got 2 positive answers. So you're probably wondering, hey Mr. Ordonez, well, if I plug in a 3 in there as one of my answers, okay, because remember, we're finding tu from there to there, but tu is equal to x minus 7. If I plug in a 3 into there, what's going to happen is that I'm going to get 3 minus 7 is equal to negative 4. Obviously, that's not one of our answers, and a lot of people will say, well, the answer is C. No, that's wrong, because -4 is not the same as 4. The other thing is, if we're talking about length, if we're talking about distance, we are not talking about negative numbers. That shouldn't even come up. If I tell you to go 2 miles, if I tell you to run 2 miles, you cannot run -2 miles, okay? You can only run in a positive direction. So that answer for 3 does not work, because 3 minus 7 is going to give you -4, and that does not simply work. Okay, so we're going to try my other answer here, x is equal to 10. So when I plug in my 10 into there, okay, you're going to see that 10 minus 7 definitely does work. So my answer must be E. Okay, so be careful with some problems like that. I know it could be confusing because you're not sure which one to use, but plug in and check, okay? All right. We're going to be talking about area, and area it could be pretty easy, but it could also be pretty challenging. These ones here are very easy. It's kind of like review. The formulas for areas are all right there, okay? So if you have a square, you multiply s times s, or the side times the side, and then you get the area there, the length times the width there for a rectangle. We also have parallelograms, which is just the base times the height. We also have trapezoids, which is half times the height plus a plus b, where a is the first base and b is the second base. And then we also have the area for a triangle right there, and so on and so forth. Okay? Okay, so area right there. How do we find that area right there? All I have to do is multiply length times width, or side times the side. We know that 9 times 9 is definitely going to be 81. So that one is very easy. So let's go ahead and move on to the harder ones. This one also very easy as well. We know that the area for a parallelogram like this one here, it's base times the height. In this case, the base is going to be 12. The height is going to be 9. So 12 times 9 should be 108. Okay? Very simple problems, guys. I am trying to do those faster because the problems that we're going to see in a little bit are a little bit more difficult than that. Okay? Let's take a look at this one right here. It seems that we have a lot of things going on in here. First of all, what I'm going to do, and the way I like to do this, is you have to realize that you have two things. First of all, you have a rectangle. Okay, so I'm going to call that area 1. Okay, and I'm going to try to find the area of that rectangle. Well, that's very easy. All I have to do is multiply the length times the width. Okay, in this case, the length will be, or it could be the width as well. It will be 1.7, and this will be 4.5, so times 4.5. That's going to give you area number 1. So 1.7 times 4.5, that's going to give you 7.65. Okay, now let's figure out what the area of this triangle is. Okay, that's area number 2. We're going to call that area 2. Okay, and then we're gonna add the two areas together, and then we're gonna get an answer. Now, as you can see, that's obviously a rectangle. So the area of a rectangle is half times the base times the height. The height, the base in this case, is where you have to be careful. From here to here, it's not 6.5. 6.5 is from here to there. Okay? Careful there. 6.5 is the whole thing. So if this right here is 1.7, because this is 1.7, so the top has to be 1.7. How do I get this portion right here? Very simple. I'm going to subtract 6.5 minus 1.7, and that's going to give you 4.8. Okay? So now I kind of have everything that I need now. So the base, one more time, is going to be 4.8. Okay, the base here times the height, which is 4.5. You can switch those around, but you still get the same answer. So we got 4.8 plus 4.5. Why am I adding? It's multiplication, guys. 4.8 times 4.5 divided by 2 should be 10.8. We're going to add my first area plus the second area, and that should give me my final answer. Which I got, so area 1 plus area 2, so 7.65 plus 10.8 should give you your final answer, which in my calculator I got 18.45, which I see that it's C. Okay? All right. Very good, guys. Very good. All right. We also have rectangles. Not rectangles. I'm sorry, guys. We have triangles here that are very easy because we already know the area of a triangle is half times the base times the height. We just have to identify what's the base and what's the height. The base in this case will be 4. Okay, and the height in this case, they're giving it to you here, is 9.4. So half of 4 is 2. 9.4 times 2, I'm going to use the multiple choice option. It should be 18.8 as well. Okay, so those seem to be pretty easy, right? Probably the hardest ones here are 9 and 10. Those are not that difficult either, though. Okay. Number 13, same idea, guys. We have the area is half times base times the height. So the base in this case will be 5. The height will be 3.3. The reason why I decided to do this multiple choice is because I don't want you to get the wrong answer just because you missed a decimal. So 5 times 0.5, by the way, 0.5 is like multiplying times half, times 3.3 is 8.25. So that should be E. So when I multiply this right here, that half, you can write it as 0.5 as well. That's something to consider. Okay, so that is number 13 there. Let's go ahead and talk about number 14. Now this right here, it's more challenging. Okay, here is Y, and this is where geometry B becomes a little more difficult. Here's the problem with this problem right here. The area is half times the base times the height. But unfortunately, I don't know what the height is. It's not given to you here. But we can actually figure out what it is. Here's how. Okay, here's how you can figure that out. First of all, let's draw a line right there for the height. Okay, and we need this right here. And we have to remember something from geometry A. So I know that the whole thing right here is 180. So if the whole thing is 180, this should be 40. Okay. So how am I gonna find this height right here? Well, we're going to use what we call SOHCAHTOA. This is probably where you're like, oh, not this again. Okay. We have to find the height there. Okay. So we need the opposite. And we need to use, in this case, if this is a right triangle, we need the hypotenuse, so the H. So we need O and H. Okay, so we need O and H. Okay? So here's how we do this. Remember that SO means sine of theta is equal to opposite over the hypotenuse. In this case, okay, sine is the theta in this case is 40. The opposite, this is where it gets a little bit tricky. This O is this H right here. So I'm going to actually put H for the height. And then the hypotenuse, remember that big H is for hypotenuse, not for height. The hypotenuse is 40. How do I find the height now? The height is going to be 40 times sine of 40. Okay, so I'm going to go to Google and I'm going to type in 40 times sine of 40. See what I'm doing there? Oh, but this is in radians and we need it to be in degrees actually. Okay, so let's try this again. 40 40 times sine of 40 is 25.71. Okay, and we need to do this in degrees, not radians, degrees. Okay, so 25.711. So this right here is 71. Why did I say 71? 25.71. 71. Let's add one more. 15. Okay. Are you with me so far? I know this is completely different than what we have been doing so far, but it's just the way it is, guys. All right. So now we have everything that we need. So the base in this case will be 21, and the height will be 25.7115. You know, it was a lot more challenging to do this now. So 0.5, which is half, times 21 times 25.7115 is 269.97. When you round that up, the answer should be D. Okay, let me verify that. Yeah, the answer should be D. So my answer for that one was 269. Okay, hopefully that wasn't too hard. I'm going to, you're gonna do number 16, which I'm gonna help you a little bit to set it up. Remember, you need to find the height of this. So I'm gonna move this one here. You need to find this right here. You gotta find what this is right here. Then you're gonna use, one more time, you're gonna use sine to do this. Okay? Alright, hopefully that's not too difficult. Hopefully. There is technically a formula that you can use for this, and let me actually give it to you. See if you can understand it or not. Okay? So the formula is the following. If I have a triangle, so it might be easier if you use the formula. It might be. I'm not saying that it won't, but it might be. If you have a triangle like that, and you have A, B, and C, the opposite of the triangle, or the opposite sides of each angle, is going to be little c, this is going to be little a, and this is going to be little b. And here is the formula. Okay, ready for this? The area using the formula is the following. It's half times little a times little b times sine of my big C. Let's see if I can actually use that formula in here. But we have to identify what we have. So if this is A, okay, that means that this is big A. If this is B, that means that this would be big B. Okay, remember, it's the one opposite to each other. Then this right here will be C, and this will be little c. I know it's kind of confusing there, but the idea is that the C is in the middle of A and B. As you can see there, the C is in the middle of A and C. So to find the formula, to find the answer, I'm going to multiply 0.5, which is half, times A, which is 27, times B, which is 37, times sine of 144. Let me actually use calculator here. So 0.5, so 0.5, I hate this calculator, 0.5 times 27 times 37 times sine, and it was 144, 293.59. Which in a sense it's E. Okay, so you're probably wondering, hey Mr. Ordonez, that was probably a little bit easier than what you just did on number 15. Well, it is, but it's not as fun as what I did on number 15. I think number 50 makes sense to me. In that way, I didn't. But if you feel like the formula is a lot easier, even if you don't know what you're doing, then that's fine. Use the formula. So you can either do it like you did it on, like I did on number 15, or you can do it like I did on number 16. Okay, I'm gonna set up number 17, and I'm gonna have you do number 18 all on your own. Okay, but 17 I'm gonna set it up for you. So the area is the following: is half times A times B. Okay, I'm gonna tell you what A and B is, times sine of big C. So in this case, if this is A, then this is big A. If this is B, then this is big B. Then this right here will be C. Then this will be little c. I'm sorry, yeah, little c. So using the formula, A in this case will be 38, B will be 44, okay, and C will be sine of 96. You plug all that into the calculator, that should give you an answer. And I'm gonna have you do 18 on your own. So again, if you didn't write this formula, here it is one more time. You could also look for it. It's called a non-right angle triangle formula, and it's very helpful when you're looking for that, for non-right triangle formula. Okay, all right, let's move on. Okay, this is where it gets very nasty. Okay, because it is a lot more difficult to do. Okay, so in here, I'm being asked to find the area of a polygon. Okay, what is the area of a polygon? Well, if you look at the formula sheet, or it might not be in the formula sheet, so let me take a look. Okay, it's not in here, so let me give it to you. So what we're gonna be doing is, I'm gonna look on Google area of a regular polygon, and I already know what it is, but I want to confirm it for you. So one way you can find the area of a polygon is like this. The area is equal to half, and this A is called the apothem. Okay, times P, which is the perimeter. Probably like, what are you talking about, Mr. Ordonez? The apothem, okay, if you have a regular polygon, and I know I'm skipping a lot of stuff because, you know, we can't go over this in so much detail. First of all, a regular polygon, and hopefully this is something that you have seen before, a regular polygon is when you have, you know, a shape like this. You could have 6 sides, 7 sides. It's a polygon, so it means that it have multiple sides. A regular polygon always have the same size, so they're always the same like that. Okay, so if that one is A, all of them are A. Okay, so the area, so the apothem is kind of like what we call the radius. Like in a circle, Okay, this will be the radius. The bottom is like the radius for polygons, okay, for regular polygons. So this portion right here, we call it the bottom. And I should have put a bunch of A's like that because that's going to be confusing. But let's call this, let's just put a 3 right there. Okay, so this right here will be the bottom.
Automotive engine block and cylinder head.
So that's the bottom. Okay, so the bottom in this case would be 13. The perimeter. The perimeter is when you add all the sides. Well, if this is 45, this is also 45, and this will also be 45. So 45 times 3 will be 135. Now usually you get the perimeter like this. It's the number of sides times the side. Okay, that's probably a little bit more confusing. So we're gonna multiply 13 times 135, divide that by 2, you get A77.5, which is C. So same idea for number 20. You want to use this formula here. Half of the bottom times the perimeter. The bottom is going to be this right here. And the perimeter, you have how many sides? We got 1, 2, 3, 4, and 5 there. So the perimeter is 5 times this right here, 14.5. You get that there, you get the perimeter, you plug that in, and then you get your answer. Okay, same idea with number 21. Let me actually do this one for you. So we have area, half of that bottom. Okay, times the perimeter. The bottom in this case is 5.5. And the perimeter in this case we have 1, 2, 3, 4, and 5 there. So technically it's 5 times 8 is the perimeter. So remember, the perimeter is all the sides added together. So we got 0.5 times 5.5 times 5 times 8. And we're going to get 110 actually. So the answer will be D. So those are not too hard, hopefully. These ones are the ones that are more challenging. Okay. Okay, so let's see if we can actually do this one here. So you're probably wondering, hey, but you know what? It seems like we're missing something here. Okay, we're missing something. Okay, it seems like we're missing something. And what we're missing in here is that we have the bottom, but the perimeter, we seem to be lacking that. Okay, we don't have the perimeter in here. So, okay, so how do I find that? Well, that's the complicated part of all of this. Okay, so we are going to use what we call special right triangles, which I don't like to use, but we're gonna have to, guys. So first of all, you have to realize that what you have here. So if I break this apart, I know, okay, first of all, since all the sides here are congruent, okay, those are all congruent, then 180, because that's the number of angles that we have, so 180 divided by 3, then that means that each one of those should be 60. So if each one of those is 60 and I break this apart here, that means that this right here should be 30. Okay, this is 90. Then that means that this must also be 60. Okay. We need to use what we call special right triangles. Special right triangles, which is a little bit complicated. Special right triangles. So we need to review that just a little bit. If I have a special right triangle, and we're gonna say this right here is called a special right triangle, it's 30, 60, 90. So 30, 60, 90 triangle. And it's 30, 60, 90 triangle here, and this is what we're gonna review. And this should have learned in geometry A. So in a 30, 60, 90 special triangle, here's what we should know. If this is 30, and this is 60, and this is the right triangle, then if this is 2a, then this would be a square root of 3, and this will be a. And you're probably wondering, Mr. Ordonez, where are you getting all this from? Well, I just went on Google and typed in 30, 60, 90 triangle. That's all I did, honestly. So 30, 60, 90. They're called 30, 60, 90 special triangle. Okay. All right. So let's try to understand what we have here. So the A in this case is this right here. And this right here, it's 11 divided by 2. Because this 30 is this 30 right here. And this 60 is this 60 right here. You just have to see it there. So if A right here, it's 11 over 2, then this right here, this A, I'm going to replace it with 11 over 2. Okay, so that means that this right here is 11 over 2 square root of 3. Which means that if that's 11, if I multiply this by 2, because it's the whole, we want the whole thing there, this right here will be 11 square root of 3. Okay, so now we can do the problem. So it's 0.5 times the apothem, which is 11 over 2. I'm going to write that as a decimal, 5.5. And then the perimeter is 11 square root of 3 times 3. Because we have 3 sides. So we put that all on my calculator. And let's see what I get. gotta do the square root of 3. I get 157.18, which is B. Okay, so you're probably like, oh my god, that was pretty challenging, because you have to use the fact that you have a special right triangle. Okay, now let's deal with this one here. And I'll do a couple of those for you, because those are pretty challenging, guys. I'm not going to lie, they are challenging. So I'm actually going to have you do number 24. And I'm going to take a look at number 25 for you. So once again, guys, we have to realize what we have here. So first of all, how do I find what those are supposed to be? Okay, what are those? Those are just all the same. So let me see if the formula sheet has it for you here. Okay, so this part right here, it says the sum of angle measures is 180 times n minus 2, where n is equal to the number of sides. Okay, so if I go back to my formula here, so the sum of all the angles is equal to 180 times n minus 2, where n is the number of sides. We got 1, 2, 3, 4, 5, and 6. 6 minus 2 is 4. That means that is 180 times 4 is 720. I know this is a lot of information, guys. So 720 times 1, 2, 3, 4, 5, and 6. So if I divide each one of those by 6, I get that each one of those have to be 120. Okay, so each one of those is 120. So now let's talk about the triangle here. I'm going to create a triangle there, and I'm going to use special right triangles. So if this whole thing was 120, that means that this right here was 60, which means that this is 30. Okay. Now, using special right triangles, remember, special right triangle, 30, 60, 90, special right triangle. Okay, identify what you have. This is 30. This right here will be 60. Okay, this portion right here is this right here. In a special right triangle, okay, this will be a square root of 3. This will be a, and this will be 2a. Okay, that means that the a in this case is actually 6. So this right here will be 6. So that means that this right here is 6, which means that the whole thing times 2 will be 12. Okay, hopefully that's making sense. I know this is one of the hardest lessons, guys. If you don't have those, special right triangle is something that you were supposed to see in Geometry A. If you don't have that down very well, I recommend that you review that, or you just go to YouTube and research that, because it is something very important that we are using here, and it's hard for me to to review it, but I'm kind of giving you a small review. Probably it's not enough, but I'm trying my best here to make this more clear for you. So we know that the area is the apothem times the perimeter. The apothem in this case is 6 times the square root of 3. The perimeter is 12 times the number of sides, so 6 times 1, 2, 3, 1, 2, 3, 3, 4, 5, and 6. Ugh. I promise you I don't have the coronavirus. Or I might, I don't know. Alright, 6 times 6, I don't actually. 6 times 6 times 6 times the square root of 3. Divided by 2. I get 180. Did I do something wrong here? Oh, I'm sorry. The perimeter, the side is actually 12. So that should be better there. So it's 12 times 6 because 6 sides. So 1, 2, 3, 4, 5, and 6. Yeah. Okay, that makes more sense to me. Okay, so let's try this again on the calculator. That's why I'm giving you multiple choice, because if you get something wrong, you know, at least you check on the multiple choice and you say, oh shoot, I messed up. That's why I'm doing multiple choice for all of this, because multiple choice should at least help you with that, to check your answers. And I get 374.1229, so I'm guessing it's gonna be A. Okay, I will do number 26 for you, or at least I'll set it up for you, because that one is actually a little bit different and it's a little bit more challenging. So this one right here, remember that if this is 60, then this right here will be 30 and this will be 60. So we have what we call a special right triangle there. Special right triangle. If this is 30 and this is 60, if this is A, then this would be A square root of 3, and this would be 2A. In this case, the A, okay, is 16, as you can see there. So this means that this right here, from there to there, is 16 square root of 3. Twice as that, twice as big as that, is going to be 32 square root of 3. So I'll just set it out for you guys. The area of this one will be half times the apothem, which is 16, times 32 square root of 3 times the number of the sides, which is 3. Okay, figure that out, and then you give me an answer for that one, and then see if you can do 24 and 22. I know this is hard, I get it, it is very challenging, but you know, it's just what we have here. Okay, this one here, this one, we do need the apothem. Okay, we need to figure out what that is. So if this whole thing is 12, this would be 6. This is actually a little bit more difficult. So we need to find that thing right there. and we have to identify that special right triangle. Okay? So this whole thing right here should be 120. And that is, I get that because if you have 1, 2, 3, 4, 5, and 6 right there, you know, the sum of all the angles should be 180 minus, you know, it was n minus 2. 180 and then 6 would be 4. So it's 180 times 4 is 720. And then 720 divided by 1, 2, 3, 4, 5, and 6 should be 120. So each one of those is 120. Okay? So that means that if that whole thing is 120, then this will be 60. Okay, this will be 30, and this is my 90-degree angle. Okay, so let's talk about our 30-60 triangle. Okay, so I don't like to write like that. So we have a 30, a 60. So if this is A, this will be A times the square root of 3. And this will be 2A. Okay? All right. So the A in this case is actually this right here would be 6. Okay? As you can see there. Then that means that this, I'm going to replace that A and I'm going to put a 6 right there. So the bottom, I know it's kind of difficult to see, is 6 square root of 3. So the area of this would be half times the bottom, which is 6 square root of 3, times the perimeter. The perimeter is 12 times the number of the sides. We already said it was 6. I'm multiplying all that out, and I actually got 374.12. Okay? All right, very good. I'll have you do number 28. Hopefully you can do that one. Number 28 and number 29 are very similar. So I'll do 29 and see if you can follow what I do and then apply it to 28, okay? So on this one here, we already talked about that each one of those is 60, which means that this is a 30, this is a 90 degrees, and this will be a 60. So remember, a special 30, 60, 90 triangle here. I always like to draw it. It helps me a lot. If this is 30 and this is 60, then this will be A. This will be A square root of 3, and this will be 2A. We haven't used this yet, but we will eventually. You'll see how. Okay, so we got A there. A, remember, if this whole thing is 12, that means that this right here is 6. Okay. All right, so here's where you have to be kind of careful with this, because this right here, well, it's 6. as you can see there. Okay, that's 6. That means that when I solve for a, I get 6 over square root of 3. So this right here will be 6 square root of 3 right there. Okay, so this right here will be 6 over the square root of 3. Okay, so the area of this is half times the bottom, which in this case is 6 over the square root of 3 times the perimeter, which is 12 times 3, because we have 3 sides. Let's plug all that into the calculator. And if you're wondering how do I plug all that into the calculator, let me actually do that for you. But you're probably wondering that too. So what I do is I start with the 0.5, which is half, and then I have that 6 divided by the square root of 3. So I'm going to put parentheses, and I'm going to put 6 divided by the square root of 3. The square root of 3 is right there. Let me close that parenthesis. And then 12 times 3, which I could actually just multiply 12 times 3 is 36. Okay. And actually I forgot to close a parenthesis there. Oh shoot. Let me see, how do I go back? Would that work? Should. 62.35. Okay, so I get 62.35, which is that right there. Oof, thank God that worked. Okay, let's move on. That was 29. Let me verify that for you. Yes, that's right. Okay, so I know, guys, kind of difficult. I get it, you know. Number 28, number 30 there. Okay, let's actually do the hardest ones of all of them. This stuff is hard. So there's not a good way to put it. It's difficult to grasp at first. Okay, and then when you do a couple of examples, then you start getting a little better. All right, if you feel like you need help, let's reach out to me again. Okay. All right, so again, this is the same idea. We have to find the area of the polygon there, and it's the bottom times the perimeter. This right here is not the bottom, okay? This right here is the bottom. So it seems like we need to figure out what that bottom is, and we also have to figure out what the perimeter is. So we have to figure out two things with all of this. And we need to do that using special right triangles. Okay? So hopefully this is not too difficult. First of all, you have to realize what you have here. How many angles you have? 1, 2, 3, 4, 5, and then 6. Okay, we have seen before that is 180, 6 minus 2 and minus 2. So 180 times 4 is 720. So all those angles added together is 720, but then I divide that by 1, 2, 3, 4, 5, and 6 angles. And I get 120. So each one of those, I already know that each one of those is 120. So if each one of those is 120, that means that this right here has to be 60, which is half of 120, which means that this is 30. So we have, once again, a special right triangle. Okay, so I'm gonna draw my special right triangle and I'm going to match it with that one right there. So again, this will be my 30, this will be my 60. If you wanna, I can match it with colors as well. Let's see if I can do this well. This right here is this. So this one matches with that one right there. This right here, it's this one. This one here matches with that one right there. Okay, so they're saying that this right here, remember, special right triangle, if this is 2a, then this is a, and this is a square root of 3. So they're saying that this side right here, let's do that with green, this right here with green, they're saying that it's 8. So if 2a is equal to 8, that means that a is equal to 4. You guys see that? If 2a is equal to 8, then a is equal to 4 if I just divide by 2. Then that means that this is 4, and this will be 4 square root of 3. Okay, so now the red is 4 square root of 3. The purple is 4. So the whole thing, if half of that is 4, then this will be 8. So the area, once again, is the apothem times the perimeter. The apothem is 4 times the square root of 3. The perimeter, in this case, is 8 times the number of sides. It's 1, 2, 3, 4, 5, and 6. Let me plug all that into the calculator. So it's going to be 0.5 times 4 times the square root of 3, 4 times, and put square root of 3, times 8 times 6. Well, we already know that 8 times 6 is 48. We get 166.27 or 166. Which translates to this right here. Okay, that wasn't too bad. I don't think it was that bad, right? Hopefully with the colors and stuff, I don't know, it will make more sense. 33 and 34 are easier. The harder one here is number 32, so I'm actually going to do that one, and you get to do number 33 and number 34. 33 and 34 are very similar to 31, so take a look at what I did on number 31 in order for you to do 33 and 34, okay? But I am going to do number 32, which is a more challenging one. Well, it's not that bad. So this right here is the apothem. Again, this right here, those two are the same. As you can see, they're the same. Okay, same problem. So this, we already know that this is 60, and this is 30, and this is my 90 degrees. Okay, so let's see what I have here. This is 30, this is 60, this will be my 90 degree. Okay, this red portion, the apothem, is this right here. This right here is that right there. And then the green portion is what they're actually giving us. If you go on Google And you will see a 30, 60, 90 triangle is like this. This will be 2a, this will be a, and this will be a square root of 3. So in this case, 2a is equal to 28 square root of 3 over 3. Okay, so let me do this on the side here. So if 2a is equal to 28 square root of 3 over 3, we want to figure out what a is. All we have to do is divide by 2. And we get a is equal to 28 divided by 2. It's actually 14, so you get 14 square root of 3 over 3. So this right here is 14 square root of 3 over 3. The a here, we're going to replace it with 14 square root of 3 over 3 times square root of 3. Square root of 3 times the square root of 3 is 3. This and this cancels, and we get 14 there. Okay, so again, the area is half times the apothem times the perimeter. The apothem in this case is actually 14. Okay, the red portion. The purple is 14 square root of 3 is 3. So remember, that's twice as big. So I need to get this right here. I was just checking 31, just making sure I got it right. Okay. Sorry, let me go back to his. So the apothem in this case is 14, as you can see there. The perimeter, we have to multiply this times 2. So it will be 2 times 14 will be 28 square root of 3 over 3. So that's what we're actually going to put here. 28 square root of 3 over 3 times the number of sides we already know is 6. Okay, so let's see if I can actually put all that on the calculator. Okay, and let's see if I get a right answer. So first of all, I'm gonna put 0.5 times 14 times 28 I'm gonna put parentheses 28 times the square root of 3 divided by 3 there, parentheses, times 6. 678.96. So I actually got a more precise answer than the multiple choice. So number 32 should be 679. You're probably thankful that I did that one for you, because that one is more challenging. But that's how you do every single one of those, guys. I know this is a lot more challenging, and it will get a little bit difficult as we move on, because we're going to be doing surface area, and we're going to be doing other things that are quite challenging. Okay, so you'll see later. Hopefully this makes a little bit of sense for you. All right, so there it is, guys. That's what we have there. So you do 33 and 34. 33 and 34 are similar to 31. I'll see you guys on the next video.